Okay, so it was an exciting game, though. It was exciting. I mean, I wish we'd won, but I mean, it was exciting. I mean, of course, and then Rico was sitting up there behind me, so he's having a good time. All right, so this asks about the 5-number summary. Now, y'all, it's been a hot minute since we did that. Okay, we did that early on in the semester. Does anybody remember what things are included in the 5-number summary? What do you think, Camden? Close. Okay, the median's in there. We talk about the minimum. There you go. The max, quartile 1, the median, and quartile 3. It's been a hot minute since we've done all that. Okay, so when we talk about the 5-number summary, that's what we're talking about. Okay, and so when we're doing the 5-number summary, we can use an applet, all right, to do it. Okay, and it's going to be that when we get in there, it's going to be one quantitative variable. Okay, and I think it's a single group. Okay, so on our applet, this is the one we're going to use to do the 5-number summary. Like I said, it's just been a hot minute since we've done all that. Okay, and the good news is it gives me all those values, which is nice. So let me switch over to that applet and get those values put in, and let's see how we did. Let me get mine out so I can see what I got. Okay. So we switch over. Remember, it's staplets.com. Is that right? Okay, let me jump. Let me add it. STA. Not Starbucks, although that would be good. Staplet. Staples. Let's do Staplet. There it is. Okay. So staplet.com. And we're going to do one quantitative variable single group. So it's the 4th one down. Okay, and we can just say it's bowling scores because that's what we're talking about. And then we put our scores in, okay? So 145, 257, 280. Cameron, these scores decent?
Well, the 280 is good. The 100 and 124.
Not so much. 300's perfect score, right?
Yes, ma'am.
All right, it's just been a hot minute since I did that. Oh, I forgot the 100.
So
100.
I think it's pretty much you have 9 spare and then you strike out.
Okay.
With that, I think that would be like 287. Is it 9 spare and then you strike out?
All right. 210, 225. Okay. And then we begin analysis. Okay. So it's going to give me a lot of things. It'll show me a dot plot. But right here where it says summary statistics, at the end is where we get those values that we needed, all right, for the 5-number summary. Our minimum, quartile 1, our median, quartile 3, and our max, okay? Don't care right now about the mean and the standard deviation for this question itself, but it gives me those numbers at the end. So that's that applet we hadn't used in a hot minute, okay? So if we jot those down, my minimum was 100. My first quartile was 134.5.
And it seems like they're not very consistent.
Yeah, I agree. This person was struggling. 210, 243.5, and 280, okay? So what we're going to talk about today is sometimes it's hard to get an entire population's worth of data, okay? So if I wanted to know, the height of every person in Gallatin, that'd be hard to do, okay? I mean, that'd just be hard to do. So we end up doing a sample. We get a smaller group that's representative of everybody, has as little bias as possible, and we talked about some of the ways to do that. And we use that sample, calculating all the data, the statistics, and use it to make predictions about the entire population, okay? And so that's what we're going to focus on. How do I take a big group, and we'll scale it down to a small group, and then calculate some information and make some decisions about the whole group based on the small group. All right, so that's what this whole chapter is about, using the small group data to make predictions about the big group. Okay, So here are our learning targets today. We're going to talk about what's the difference between what we call a parameter and a statistic. Okay, those are just vocab terms. Then we're going to do a sampling distribution. That's what I say. We're going to take a smaller group, all right, and not use the whole group. And then we're going to evaluate a claim about the whole group, all right? So using that small group to make a decision. So let's take a look right here, all right? So here it's talking about a test in a class, and it says we take a sample from a population. So we'll use the average from the sample to estimate the average for the population. Okay, let's say in one very small school, there were only 5 students who took the Chapter 6 test, and these were their scores, 60, 70, 80, 90, and 100. Okay, so what I want you to do is to pick 2 of those scores and find their mean. Okay, what would I do to find their mean? Add them up and divide by 2. Okay, so it doesn't matter which 2 you pick, all right? We just picked 2. So I'm going to pick the 80 and the 90. Okay. And if I add those up, that'd be 170. And then I divide it by 2. That would give me a mean of 85. Okay. So if I take a small sample, okay, there were 5 scores. I only picked 2 of them. All right. If you picked 60 and 80, what would your mean be? It'll be halfway between 60 and 80. 70. Yeah? All right, so if we go 60 to 100, the middle would be 80. All right, so let's do this. Let's figure out all the possible samples of size 2. In other words, how many different combinations of all these scores could we make? All right, I could take a 60 and a 70. I could take a 60 and an 80, a 60 and a 90, a 60 and a 100. We agree? Okay. Now let's start with 70. Would I want to do 70 and 60? I've already done it. There's no need to do it again. All right. So I could do a 70 and an 80, a 70 and a 90, a 70 and a 100. There's no reason to repeat anything. Okay. If I start with 80, what are my options for 80? 80, 90, and 80 and 100. Okay, for 80. And what about if I start with 90? 90 and 100. Okay, so those are all my possible sets of 2 that we could do. Okay, now let's find the mean for all of those. All right, we're going to add them together, divide by 2, all that kind of stuff, right? So if I did 60 and 70, the mean would be 65. 60 and 80, the mean would be 70. 60 and 90, 150 divided by 2, that'd be 75. Sorry, I'm doing math in my head, which is dangerous. 60 and 100 would be 80. Okay. So just doing the means. 70 and 80 would be 75. 70 and 90 would be 80. 70 and 100 would be 85. Yep. Okay. All right. 80 and 90 would be 85. 80 and 100 would be 90. 90 and 100 would be 95. Okay. So I'm just doing the means of those sets of 2. Okay. So just doing the mean. All right. Does everybody remember that symbol? X bar stands for mean. Okay, so just as a reminder, okay, it's an average. It's a little notation. Okay. So let's do this. Let's take those blue numbers that I just got and let's make a dot plot. Okay, what's a dot plot? It is, but what does it look like when we do a dot plot? It's a little graph. We put dots on it above the numbers that matter, right? So let's go in here and let's put our dots on here. So I had 1 at 65. I have a 70, a 75, and an 80. All right. Then I do the next column. I have a 75, an 80, and an 85. The next column, an 85 and a 90, and then a 95. Okay, so there's my dot plot. Right. Now, when we sample this, remember these were samples of size how many? How many numbers were included in every average? 2. Okay, so this is a sampling distribution of my sample mean. Okay, sampling distribution of my sample mean. Okay, I only took 2. If you're on your phone, I need you to put it away. Focus, let's get it done. Okay, so it's sampling distribution of our mean. Okay. Now, we talk about what's called a parameter and what's called a statistic. Okay, the parameter is always the entire population. So P and P. All right, parameter goes with the entire population. All right, so that's my parameter. It goes with my population. Okay. My statistic is my smaller group, my sample. Okay, so where I use 2 numbers to do an average or to do a mean, that's my statistic. It came from that small group. So parameter, population, P and P. All right, statistic, small group, S and S. All right, so you can know which one goes with which. All right. So the last thing it asked me down here is what's the mean score of the population of all 5 students? How would I calculate that? How would I calculate the population mean score? Which numbers would I use?
You would use the parameter.
Yeah, I'd use that parameter, the 60, 70, 80, 90, and 100, okay? We'd use all of those. So I'd add them all up. So 60 plus 70 plus 80 plus 90 plus 100. And then what would I divide it by? 5. Okay? I'd add it all up, and I would divide by 5. Okay? And we should get 80. Right? Now, the symbol we use for the population mean is that kind of cursive U. Okay? Remember, that's population. Mean. Right? When we use X bar, that's my sample mean. That's the mean of the smaller group. Okay? So when I use the curly U or the curly M, that's the population mean. When I use the bar, that's my sample. So those are 2 important notations. Okay, so keep those right there. Okay, now let's talk about what we think is going to happen. So we know the population mean here was 80. Okay, when I had 5 scores and I took 2. Well, let's look down here. For this one, how many students do they have? 40. Okay, they have 40 students, and this time they only want me to pick 5 of them. All right, so I'm just going to pick a random 5, and we're going to calculate a mean. I'm going to take that one, and that one, and that one, and this one, and this one. Okay, just because I liked where they fell in the thing. All right, are there lots of different versions of 5 scores you could choose? Sure. Okay, we could all do that. And so if we did, right, if I did that mean, so that would be an 89, a 91, a 99, a 75, and an 82. Okay, so let's calculate that mean and see what we get. Get a calculator. All right, 89 plus 91 plus 99 plus 75 plus 82. Okay, that gives me 436. I'm going to divide it by 5. It would give me an 87.2. Okay. Now, if we all picked a bunch of different things, okay, what do you think the dot plot's going to start to look like? Any thoughts?
It's gonna look more skewed right or left.
Yeah, well, it's going to get more defined. All right, we're going to be able to tell better, is the data skewed? Does it look uniform? Does it look symmetric? So the larger my sample, the better my graph's going to look, right? So let me give you a version of this graph. Copy this down for me. All right, and it doesn't have to be perfect, but I just want to show you if we took several samples of size 5, how this data begins to change from what we had in our original dot plot. Okay, so this is sampling distribution. And one of the things you'll see them do is put n equals 5 or n equals 2. That means how big was your sample? All right, we chose 5 of the 40 scores. All right, we chose 5 of the 40 scores. So I'll give you a second to kind of copy that down. It doesn't have to be perfect, but just to give you some idea of how the data gets a lot more detailed, or the plot gets a lot more detailed as we change the sample size. All right, my numbers get a lot more specific. Okay, what do you think would make it even more specific? If I took a bigger sample or a smaller sample? Bigger, yeah. If I took, let's say, 8 scores, it would get even more defined. If I took 10 scores, it would get even more defined, all right? What do you notice, or how would you describe the shape of the first one that we did up here? Remember, when we talk about shape, we talk about symmetric, skewed, uniform. What do you think? Uniform would be they're all the same. So it looks pretty symmetric, right? But the problem is with symmetric, we have a definite peak. Okay, so do we have a definite highest one on this one? No, I got it at 3. But if I go down here to the bottom, does it look a lot more symmetric? Yeah, in fact, it looks pretty darn close to being perfect. Okay, so the bigger our sample size, the more defined my data gets, which is kind of cool. All right, so if I wanted to find the population mean of all 40 students, what would I have to do?
Put all their scores in and divide it by 40.
Yeah, put all their scores in and divide it by 40, okay? I'm not going to make you do that. Here's the answer, all right? You should have gotten you would have gotten 82.1. What symbol would I put there for the population mean?
The word M.
The weird M, okay? I would put 82.1. And that's what today is about, okay? Can you find a population mean? Can you take a sample and get a sample mean? Can you draw a dot plot? All right, all of that works through that applet that we used in the beginning. And what could we say about it? So jump over and let's talk about a few things on the back that we have to know. Okay. So not terrible today. All right. So Learning Target 1 talks about the population or the parameter and the statistics. Okay, so if I start with a population, that's my parameter. Okay, out of that population, I'm going to choose a smaller group. Okay, I'm going to choose a sample. All right, go get you some lunch.